Okay, so Karen rides her bicycle on the straight road from home to school, starting at home at time t equals 0 minutes, arriving at school at time t equals 12 minutes. During the time interval 0 to 12 minutes, her velocity in miles per minute is modeled by the piecewise linear function whose graph is shown above. Alright, so in part A, you have to find her acceleration at 7.5 minutes and indicate the units of measure. Alright, so how does acceleration relate to velocity, since velocity is what we have the graph of? So if we're trying to find the acceleration at 7.5. Acceleration is the slope of velocity, or the derivative of velocity. So we've got to find the slope of this graph at 7.5. So if I come back up here, 7.5 would be right here. So the slope's going to have the same slope as this little piece of this piecewise function. So the slope there then would be, the slope of this little piece is down 0.1, right? Because the units over here are 0.1 miles, so or miles per minute. So it's down 0.1 miles per minute over 1 minute. So basically you're finding the little slope of that line. So it's negative 0.1 miles per minute, because that's what her velocity is measured in, over 1 minute. So you get negative 0.1 miles per minute squared. So that was worth. What'd you do?
I did it all right, but I didn't put per minutes the same thing.
So let's see what they did for units here.
Do you have to put per minute squared? Did I put units per mile per minute?
So you get, if you got the point negative 0.1, but you got the units wrong, you'd get one of the 2 points. So that was 2 points. A point for the answer and a point for the unit. Alright. Part B, using correct units, explain the meaning of the integral from 0 to 12 of the absolute value of velocity in terms of her trip, and then find the value. So what is that? When you integrate the absolute value of velocity. Yep, so this is going to give us the total distance traveled. The total distance in miles traveled over the 12 minutes. And then to find the value, we'll just add up all the areas. And remember, we're doing absolute value, so all the areas count as positive, even if some of them are below the x-axis. So this first triangle has a base of 2 and a height of 0.2. So if you do base times height divided by 2, you get 0.2. Same thing for this one down here, except it's technically negative, but since we're doing absolute value, we'll count it as positive. And then there's lots of ways to break up this other part. What'd you break it up into?
A triangle, a rectangle, and
A triangle.
I did triangle only from 5 to 6, rectangle from 6 to 7, travel from 7 to 8.
And then another triangle from 11 to 12.
Yeah, oh yeah, sorry, I was just talking about triangle, rectangle, rectangle. I was just looking at
Okay, so then this one, this triangle, we would have 0.15. This rectangle, we would have 0.3. This trapezoid, we would have the average of the bases, which would be 0.25 times the height, so 0.25. This rectangle would be 0.6, and then 1 times 0.2, so 0.1. So if we add all those up, 0.4, 0.55, 0.85, 1.1, 1.7, 1.8. Is that right? If you add all those up? And this was the calculator portion, so I would highly recommend putting that on the calculator to make sure. So that's 2 points. 1 point for knowing that that was total distance traveled. Whoops. And 1 point for finding the 1.8 miles. Alright, part C. Shortly after leaving home, Karen realizes she left her calculus homework at home, and she returns to get it. At what time does she turn around to go back home and give a reason for your answer? So, when did she go back home? Did y'all figure that one out? When did she turn around and go back home?
Oh, I put T equals 2.
Yeah, T equals 2. You can tell when something changes direction when the velocity changes signs. So that's the point when her velocity went from positive, meaning she was headed towards school, to negative, meaning she was headed back away from school. So her velocity changes signs at 2. So that's when she changed her direction. So T equals 2. Velocity changes signs there. So that was worth... Where is it? That was worth another 2 points, and 1 for the answer and 1 for the reason. So 1 point for knowing that it was at 2 minutes, and even if you couldn't really articulate why you knew it was 2 minutes, you could still get that 1 point. But this is the time at which her velocity changes signs. It doesn't really matter that it changes positive to negative. You don't have to get that specific. If they asked, like, about maxes and mins, you would need to do that, but it's just that it changes signs. It didn't really matter which direction it changed signs. Alright. So then part D. Larry also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by this function, where W of T is in miles per minute for 12 minutes. Who lives closer to school, Karen or Larry? And show the work that leads to your answer. So, first off, how far does Karen live from school? Oh, she doesn't live 1.8 miles from school. She actually lives 1.4 because, remember, this part of the trip was her going back home. So really it's just all the positives added together. So if you add all those up, you get 4, 5, 5, 7, 1.1, I mean 1.4, right?
Yeah.
0.45, 5, 7.
Is 10, and this is 2.5.
Oh wait, no, just this part is her going to school. Sorry, not this part. This was her leaving home, going back, and then when she left home the second time, this total distance is how far it was from her home to school. Ugh. So it's not all the positives added together. It's just this last little part when she went back from home to school again. So 1.4 miles. And then for Larry, to figure out how far he lives from home, we're going to do the same idea that we did with Karen, but we have an equation instead of a graph. So what we did with Karen was we integrated from 5 to 12. It actually only takes her 7 minutes to get to school. But we integrated from 5 to 12. When we find area, that's what we're doing. We're integrating. So we're going to integrate from 0 to 12 Larry's velocity function. So if I do that in the calculator, I'm going to go numerical integral from 0 to 12 of pi over 15 sine pi over 12 times t. Oh, no, but I want to use t. I stored something for that. If you type in a variable and it pops up bold, it means that it has something stored for it, so the calculator's not going to treat it as a variable. So I'm going to use x here. You can clear out the variables that you've stored. If you do menu and actions, you can clear out all your variables if you store something and you have a variable you want to use. So we should get 1.6. So who lives closer to school? Karen lives closer to school. So that was 3 points. It was 1 point, it was 2 points for figuring out Larry's distance from school. And one of those points came from showing your work here. So 1 point for showing your setup, what you typed in the calculator, 1 point for figuring out his distance, and then 1 point for the rest of it, figuring out how far Karen was and her distance from school. So how'd y'all do?
6 out of 9.
I got 12.
Not good or good? You good?
We got 6.
Okay, on the 2008 test, we already did this one. It was on your take-home test. But on the 2008 test, number 4 is another one over velocity and all that stuff. And it was on the non-calculator portion, so you couldn't really do much with a calculator on that one anyways. There weren't any equations or anything, but that's another one. The other one I want to look at was on last year's test. It was 2012, and it was number 6. Okay.
I'm just gonna, since I've got copies of all of this, except for this new one you handed us, I'm just gonna use these.
Yeah, that's fine.
Just put them on your desk.
Yeah, that's fine. So for the 2012 number 6, y'all take a few minutes to try that one. It's kind of tricky. It's on the non-calculator portion, and it has trig in it. So you don't have a calculator. So see what you can do with it, and then we'll go over it.